Here we have question number 32. Again, it's a good question because we see sine effects and cosine effects. So let's think about our Pythagorean identity here that deals with trigonometry. So it states that cosine square of x plus sine square of x is equal to 1. And so really we want to bring, what I would do here is I know sine square of x is equal to 1 minus cosine square of x, and that's good because if you bring everything in terms of cosine of x, then you can easily factor this equation out. So looking at this, we know 2 times 1 minus cosine square x minus cosine x minus 1 should give us 0, right? That does become a quadratic function here. So we can further solve this and we get 2 minus 2 cosine square x minus cosine x minus 1 is equal to 0. So that's just minus 2 cosine square x minus cosine x, and then we have plus 1, right? Plus 1 is equal to 0. And so again, you can just factor this out as you would. If you want, you can say cosine of x is some variable such as z, and then you can say negative 2 z squared minus z plus 1 is equal to 0, right? You know that we're looking for two values, right? Two values that have a product, right? That have a product of negative 2 and then a sum of negative 1. So that's what we're looking at here. And so just looking at this, we know that negative 2, right? Negative 2 and 1 have a product of negative 2 and a sum of negative 1. And so we can write this as negative 2z squared, right? Negative 2z squared minus 2z plus z, and then plus 1 is equal to 0. And so we can obviously factor this out now. So we have negative 2z, right, times z minus, or it would be plus 1. So we have negative 2z times z plus 1. And then we have plus 1 times z plus 1. Now that is equal to 0. So this becomes negative 2z plus 1 times z plus 1 is equal to 0. So this is what we have over here. And now looking at this, we can obviously solve for z, but here, so we know this is our equation, so we can write this in terms of cosine of x now. So we get negative 2 cosine of x plus 1 times cosine of x plus 1 is equal to 0. So this is what we're looking at this point, right? And obviously that is equal to 0, so I can just erase this quickly. So this is what we have over here, right? And obviously we want to set each factor to 0. And so we see that cosine of x, right, is equal to negative 1 divided by negative 2. Well, that's just half. And then cosine of x is equal to negative 1, right? And so these, both of these equations over here can be solved, right? Because obviously cosine of x can equal negative 1. And so thinking about this, cosine of x is equal to 1/2. So as in the previous problem, that's just x is equal to pi over 3, right, in quadrant 1, and then comma 5 pi over 3. That is in quadrant 4. And then cosine of x is equal to negative 1. Well, think about your unit circle and think about the point where your x coordinate at some point, right, may be negative 1. And you will see that that is only at the point x is equal to pi. So our final values, or our final solutions here, are x is equal to pi over 3, comma 5 pi over 3, and then x is equal to pi. So these are our three values as we have solved this trigonometric equation here. So thanks for watching.